definitely been a wild ride. I came in as an economics major, actually. I had always been kind of interested in environmental science, but I took an intro class in geology and an intro class in weather systems. And the weather systems professor really took an interest in me. Her name was Christina Gallup, and she ended up being my undergrad advisor afterwards. But yeah, just talking with her, I did very well in her class and started to do extracurriculars with her, and she really just got me interested in environmental science as a whole. Maybe just give me a boost forward, like a couple meters. Beautiful. I'm studying water resources science, particularly with this project, the microbiome of wetlands. The goal overall is to find a baseline of what the microbiome is within wetlands in the St. Louis River estuary. Wild rice happens to be the natural plant that we're studying, and so we're looking at the interactions between wild rice and microbes at their sediment root interface, and we're also looking at competing plants to see how those things vary on a smaller spatial scale. Right now we're doing cattails. This is just for competing vegetation data. The focus is to try and catch wild rice at different life stages to see how symbiotic relationships are between the plant and microbes as it's growing throughout its life stage. There's obviously a lot of interest in looking how to better grow wild rice, looking why wild rice is disappearing from areas where it has been historically. And so this research takes the angle of maybe the microbiology can give us some sort of indicator as to why these changes are happening, and perhaps we can predict them in the future in areas, or we can see that as ways to remediate areas that have now lost the ability to produce rice. So a lot of understanding the microbiology is understanding how nutrients are moving. Really what those organisms are doing on the rooting structure is they're changing nitrogen and phosphorus, sulfur, carbon, things like that from unusable forms or decaying matter, things like that, into usable forms that the plants can then take in through the roots. So understanding this helps us kind of understand how nutrients are moving throughout wetland systems. And wetland systems are invaluable for types of nutrient cycling as far as having organisms that can decompose dying matter, recycle plants, animals, things like that. Wetlands are very, very good for them. I did research at the undergraduate level as well in the same lab I'm currently working on. I transitioned from a year op to I was a tech there for a summer, actually helping out with sewer sampling. That was the first field work I got to do, was raw sewage sampling. That smelled beautiful. Then again, wetlands don't smell too much better, so my nose has been through quite a bit, but yeah, I love it. NRI has been a great place to work so far, so I definitely enjoy it.